Well, here we go with four right triangles, and we're going to demonstrate the Pythagorean theorem. Yeah, I know. You've probably seen this before, but it's fun. So put your name down there, yabba dabba doo, and let's get to it. I'm going to start with this triangle right here. Now, I put little stops in it so you can't go nuts. So you can move it about like that. But you can't change it. You can't spin it around, and it's fixed at a right angle. So, well, we're going to make this. This is fun. Okay, yeah, I already said that. I want you to go to your tools here. We're going to grab the custom tool, the first one that says square. Now, I used to always do this the hard way, but dang, I mean, it takes forever to construct it old-fashioned way. Let's use the tools. I'm going to snap from B to C. Snap. Why? Because I wrote it that way, clockwise. Maybe I should have wrote it the other way. So now I'm going to snap from C to A. Snap. And then from A to B. I know you've seen this before. Classic math stuff. And you say, oh yeah, look at that. Now, just for fun, let's change, I don't know. Let's go up here. I'm going to change that more magenta. A different color for the big square. And, well, I guess I forgot to say a few things. I could say this is angle A. And you remember what we said. Angle A, no, it's not opposite J. It's opposite side A. So we could refer to CB as side A. B here, opposite. Now, K, that would be B. So we're just going to label them this way just for the first one because it's fun. And opposite angle C is side C. So, well, let's do some measuring. Well, actually, hang on a second. If this is a square, this and this must also be A. So I'm going to say, I'm going to say A, like that. And this side is B, this is B by B, and this is a C times C, or a C squared. Yeah, you know where this is headed. So, well, let's get to it. Because again, we're doing it the easy, fun way. You're in this class because you want to do stuff, well, you want to experience math. So, select this interior, and I'm going to measure area. Now, don't sweat it, but I know those extra characters pop up. It drives me nuts, too. So I'm going to make the font bleu to match the square. And if you want to be really fancy, you can, I don't know, is it function or is it, oh, yeah, command, go to properties, and the label, well, let's make that A squared. A caret 2. Oh my gosh, I messed up. Are you serious? It doesn't even do that. Gosh, how old is this program? So I guess you're going to, well, if you're an old school mathematician, you'll know that A caret 2 means A squared. So that's the A squared. Let's measure the B squared. Measure area. And you can ignore all those other letters. They really don't matter. But I do kind of like changing this up. I do kind of like making this B squared. B caret 2. Hey, I like that. So that's my B squared. And also in this demonstration, I'm going to measure, well, no, hang on. Let's do the calculate. If you're in version 5, you go up to number. Here, I'm in old school. I like version 4. Measure, calculate. You're going to, say that again. You're going to actually snap on right there because it's a dynamic measurement. That plus the B squared. So now you've got A squared plus B squared. And you know what's coming. I'm going to measure this. Measure area. Heavens to Murgatroyds, you knew that was going to happen. And this, again, is not a proof. We're just demonstrating. We're just demonstrating here that, actually, let's get rid of these annoying things. If I put this on here and click, I can get rid of all those. Yeah. Except I also get rid of the ABC there. God, that looks better, doesn't it? You can see that A squared plus B squared over here equals C squared. Of course it does. Move it around. Convince yourself. Why? Because it's fun. If math isn't fun, why would we do it? Now, yeah, I know, those you guys that work ahead, yeah, I got news for you. You thought we were going to do squares on all these. God, how boring is that? Let's do something else. And this may come as a surprise to you. We've got equilateral triangles. By golly, we've got semicircles. Look at this. Wonder how this is going to work out. Not like we don't know already. And how about a regular pentagon? Pentagons. Pretty sweet, huh? Now again, I'm not going to bore you with all this stuff because, well, yeah, because I'm not. Which ones do you want to measure? This one, this. Okay, you got it. Let's measure the semicircles. This looks kind of cool. Move this guy over here, and we're going to measure this semicircle. Measure area. And I guess you were going to say that's a sector. Truth be said, I guess it's the same as a segment when it's a semi, isn't it? No, you tell me. I'm going to measure this one. Area. There's the arc DF measured. Now, of course, get out of here. Move over here a little bit. You can see we spend most of a class period on this activity. You got 2 more pages to go, but you can see this is a lot of fun. So let's measure, calculate. We're going to add these 2 arcs up. Arc. 1 arc and 2 arcs equals this arc. Yeah. And we're going to measure this bad boy. I always like to change the color just to accentuate. One of these arcs is different from the other. It's nice and big. So measure that area. Swisheroonie. And you can see what's going on here. Semicircles. The area of these 2 semicircles, sectors, is the same as this one. Look at that. Is that unbelievable or what? Well, okay, you all knew about this bad boy. But what's really cool here is that this is going to work. This demonstration will work. Well, it works with squares. It works with equilateral triangles. You do that one yourself. It works with semicircles. See, I'm showing you right there. And it works with regular pentagons. In fact, it's going to work with any shape. As long as the shapes are, what's the keyword? As long as they are similar shapes, it's going to work. Nice. All right, you guys finish up this page. We're moving on. We're burning daylight. It's time to explore the converse of the Pythagorean theorem. Ready? All right, yeah, sorry, you guys can't see the tabs on this thing. Maybe I can move this like this. I got to get better at this. I got these little tabs on the bottom. There's one here for the converse. Swish. Here comes the converse. Now, we could use any shape we want. I'm going to run out of room. So, yikes. But let's go classic. We can go squares. Remember, these are the custom tools I made for you. If you are a teacher at some other school and you like to do fun stuff like this, well, drop me a line and I'll send you the files. Because making the Sketchpad files, honestly, is all the work. That's the money, as we say. So I'm going to measure these 2. Measure areas. Yeah. And this one I'm going to say is a squared. What did I do here? Oh yeah, the control. And I'm going to call that one a squared. Or a caret in this antiquated version. And yeah, you can see where we're going here. And let's compare that, and let's look at b squared. I think I made these fixed, so you can't really do much with them. But you're going to have an enlightenment, yet another epiphany. B caret 2. That's b squared. Okay, we got a squared and b squared. But now, watch this. And, just for the, I'm going to change that color. Why? Because it's fun. I always use the text palette here so I can get softer colors. You make them dark and you can't see anything. It's just not fun. So there you go. I forgot to add these 2 together. Clearly it's going to be 149, but let's stick with the program. Calculate. A squared plus b squared. 149. There it is. Now, we're going to measure this bad boy, and something is going to be different. Here we go. Ruh-roh. Oh yeah, you can see it. I know you can see it. There is something rotten in the state of Denmark here because, well, hang on. I'm going to call this c squared because I like that better. A squared plus B squared does not equal C squared. You know, if we change the precision on the machine, we could get it, but honestly, it doesn't matter how much I move it. I just can't nail it. You can see if I move off of that right angle, I don't have it anymore. I can get close, but no cigar. Well, I know that when A squared plus B squared equals C squared, that is a right triangle. No kidding. You knew that in 4th grade. Maybe you're in 4th grade now taking this class. You advanced kids just, man, you guys are awesome. I'm moving this around and we're going to see an inequality, the holy trichotomy of mathematics. Because right now, A squared plus B squared, 149, is greater than or less than. Come on. You know that is less than. So what kind of triangle does that look like? Well, it looks like it's bigger than a right angle. What's bigger than a right angle? I'll give you a hint. It starts with O and rhymes with something tooth. All right, then swing that bad boy this way. And you're going to see now A squared plus B squared is greater than C squared. Now, I'm not going to put the words in your mouth. You're going to type in the correct words here. One of them is acute and one of them is obtuse. I guarantee you, on your final exam, you're going to remember this because somebody is going to give you, I don't know, let's make one up. Somebody is going to give you the sides of a triangle. And why was 6 scared of 7? Because 7, 8, 9. Love that joke. Someone is going to give you the side of a triangle, some random thing like that. And they're not going to say, is that a right triangle? They're going to say, classify. Is it right? Is it obtuse? Is it acute? So clearly, you're going to take the squares of the two smaller numbers, add them together, compare it to the biggest number. That's the only way that it could be either obtuse or right. So that's what you're going to do. It'll be a lot of fun. Well, you already know the answer to this one. Save it for the final exam. That's exhausting. What do we got here? 12 minutes? Yeah, this is what we call the studio version because my class just did this today, and I don't know what we took, 40-something minutes, but they were smoking it. You know, okay, these guys practice this all the time. We're in the lab once a week, so it's a regular part of our curriculum. Hey, we had a discussion on triples. Now, I was trying to think of a better way to do this, but I just made this one up today. Okay, it's a little lame, but we're going to do it. I'm going to click on C. We're going to actually go transformers. We're going to translate. And I'm going to go 0 in the 0 direction, and I'm going to go 3 in the centimeters department. You got it. Of course, that's going to come up C prime, but we're going to change it to B. Okay. Go back to your Charlie there. Transformers. And you're going to translate, let's go 4. And we're going to go 90 this time. Holy polar coordinates. Batman, we got this going on. And you're going to make this, well, that's C prime, that's going to be A. So this is triangle ABC, and you know where this is headed. Oh, you know it. Missed. Edit, undo. Whenever you miss, gosh, I hate that. You know that triangle looks kind of lone. I think if I selected the segments display line with thick, that's a little better. Now we know it's a right triangle. I guess we could measure the sides, and we're going to. But I put this little right angle symbol in there too. If you remember that, click on the vertex, one leg counterclockwise to the next. That just looks cute. All right, so we're going to move over to K here. We're going to mess it up here. We're going to make sure we have room. Transformers, we're going to translate K. Let's go horizontal again. We're keeping this very orthographic. How's that for the word of the day? And, I don't know. I'm thinking of a number. How about sweet 16? Yeah, that's a good number. 16 centimeters. Now it's going to come up K prime. Yeah, that's crapple. You're going to change that. What do you want? K, Z, G. I don't want to use consecutive letters because that's leading. So I'm going to find some other letters. G. Use any letter you want as long as it's G. Well, okay. Now, maybe S. Yeah, we haven't used S all day. Now, you can connect that. That's a segment. And now we're going to do this. We're going to connect this point. Transformers. And we're going to translate this guy, again, in the 90-degree direction. the 90-degree direction. Let's go 12. Boom, done. And of course, that's going to come up K prime, and you're going to change that to Z or Zulu, depending on your inclinations. Move this thing out. Move that out of the way. See, these guys are fast. I'm going to tell you, these students eat this stuff up. And these are, this is easily done in a class period with lots of other activities going on. And I'm not talking block. I'm talking, like a 53 minutes. So, K. Oh, yeah. Remember, this is second semester. Now, if they transferred into the class, well, I guess they need some help from their friends. Let's measure some stuff. You knew this was coming. We actually made this to scale, so I'm gonna click on all these. I could change the lowercase letter. I'm just not going to do that. I'm going to measure length, and I've got here. I've got a 4 for AC. I've got a 5 over there. Holy Pythagorean triple, Batman. This is going pretty good. So I'm just going to leave that over here, all right? And then I'm going to measure these bad boys here. Measure length. Ay, where'd they go? Okay, sorry, I don't know what color I should be using. That one's 20. This one's 16, that's KS, and this one's 12. Now, straight from last chapter, similarity, side, similarity. You know how this works. I got 3, 4, 5. If these triangles are similar, the only way it can work, short to short, medium to medium, long to long. So, did I set this up right? Yes, I did. So, 3 is to, I need a different color. 3 is to 12. I hate when it does that. So, 3 is to 12 as 4 is to 16. As, what we got there? 5 is to 20. Now, you remember doing this. Gosh, it wasn't that long ago. Let's go with purple there or something. And we have this proportion, and we're going to demonstrate that it's the same. And what we could do, we could just divide out all the common factors. I need a spot for this. Okay, over here. Over here, let's divide out the 3's. I've got 1, 2, 4. Let's divide out the 4's. I got 1 to 4. Divide out the 5's. 1, 2, 4. Now, this confirms our proportion, so we know our triangles are similar by side, that tilde, that similarity. And not only that, we know the scale factor. What to what? Yeah, you got it. It's going to be 1, 2, 4. Swish. You've got a scale factor of 1 to 4. Now, let's line up the angles correctly. I should let you do that. All right, which angle here? Careful, it's not what you think. Well, C clearly lines up with K. That's the right angle. I think the S is going to go with the A. So be careful there. It looks like SZ kilo. So there you go. SZK. I better check that, make sure I'm ZK. Does that look good? I like it. I like it. Now, what we've really done here, and I'm going to make some room because you're going to get some vocabulary, and you better know it for my class. If you're in, I don't know, if you're in Thailand or something, I mean, I hope your teacher's going to want you to know it too. So, watch this. I'm going to say triangle ABC, and this is the money. This is all the money. There's the little triangle symbol. Triangle ABC is a primitive Pythagorean triple. Type it out. Now, what does that mean? Well, first off, it's Pythagorean triple. Maybe smaller font there. Let's go 36. And it is a Pythagorean triple, but where the sides are all relatively prime. It's a primitive triple. It's a triple where the sides are relatively, I don't know if they use this phrase anymore, prime. Now, 3's prime, 5's prime, 4 prime, heck no. But the three numbers together as a set do not have any common factors. They don't have any common factors, whole number factors other than 1. That makes them relatively prime. And from this, well, we have a whole worksheet on this, so you better get on it. And we're going to say that triangle SZK, it is still a Pythagorean triple. Notice I left the word out there. It is still a Pythagorean triple because I've got whole numbers for the sides. However, they're not relatively prime. So we're going to say it's a Pythagorean triple in the 3, 4, 5 family. Yes, it's all about family here. Check that out. Now that is mixing together a bunch of concepts. You are going to have an entire worksheet where you're going to take families of right triangles and solve for missing sides without using Pythagorean theorem. You're going to make some use of those similar triangles. Pretty cool, huh? All right, well, let me see. We're clocking in at 21 minutes. So if you missed my lab, you're watching these instructions, you're going to the library, and you are making this up on your time. So best of luck to you, and we'll see you, I guess we'll see you the next day. Next days are two.